Today we will talk regarding the image processing and some critical aspect of that we will review today. Um, Mainly, this is the second part for introduction to image processing. Uh, Last lecture we talked regarding the what is image and digital image, how it will build. Today we will talk regarding what is image processing and some key stage in digital image processing work. Today we will talk regarding some words and some definition which will be use them later, and maybe we can call these lecture up to um, initial lecture of next week as the foundation of our digital image processing lectures. Mainly, if we want to talk regarding the image processing method or way, we can call it the method to convert it into the digital form, means that any image into the digital form, and perform some operation, some work we want to do on that, uh, to have the enhancement image or extract some useful information from it. As you remember, we talk later that uh, by the image processing, our aim is that extract and catch the maximum information or maximum data which hidden inside the image. Or we can say that our work is that we want to give the meaning to any pictures and any data which is hidden inside the image. This image processing, we can call it as something like signal the and dispensation in which the input is image, and you know that image can be even the video frame or can be some photograph, and output can be image or some characteristics associated with the image. Uh, Even you know that maybe this can be the image or can be sometimes our output can be some movies or some clips which we will talk later. And usually this work, I mean the image processing work, including the treating image as two-dimensional signal while applying already set signal processing method to them. We talk why we call it 2D dimensional work, but in our subject maybe we will talk regarding the 2D. In some advanced form, we can see the image even in 3D. But now in this stage, we just talk regarding the 2D work. The main purpose of image processing, we can call it into the five group. First can be the visualization, which we will observe the object that are not visible or they are the backside, they are not much more in front when you see the picture. Image sharpening and restoration, which we are going to create a better image. Maybe you will see these on your mobile phone and AR section. Image retrieval, which we will seek for the image of interest, and measurement of pattern. We are going to measure the various objects in an image. What is the size of, suppose, one ball in the pictures? What is the dimension? Where is the dimension of, suppose, a specific place? And so on. So many things can be on the measurement part, and some image recognition, which we are going to distinguish the object. Suppose we want to find some cat and dog and classify them or have the distinguish between this cat and dog image inside of the photo. Then by this image recognition, we can do that job. If I want to summarize all the key stage in digital image processing, I can have this figure, which we are going to observe one by one. As you see, the first block or first part of my digital image processing stage is the image acquisition. In image acquisition, as the first step or process of fundamental step, uh, it can be as simple as given an image that is already taken by suppose some digital camera, or it's converted into the digital form. And generally, this image stage involves the processing such as scaling and some work like this. We can call this in brief as the capturing of image, and generally it involves some pre-processing such as scaling and that. But what we mean that generally when you take the image, suppose by your mobile phone, some work will come initially on that. You will see that first glance it's not clear, and after sometimes there is some algorithm or some pre-processing work on some pre-work which it's going to make it better, and after that stage, after some second, the picture quality become better. This is the image acquisition. For this blog we may talk regarding the structure of the cameras even for the next lecture. I will prepare for you to also have more information regarding this image acquisition part. Okay, then in brief, capturing is the image acquisition block that we know it as the initial stage of the pre-processing. The second part is image enhancement, which you will see. This is my captured image, and the next image is the image after image enhancement. But let us see what is this definition. This is the simplest and more applying areas of digital image processing, and basically the idea behind this is to bring the detail that is obscured or simply highlight certain feature of interest in an image, such as changing the brightness and contrast. Let us see once more the previous picture. What different we have between these two images? I mean, before enhancement and after that is that we change the illumination, and also you will see that picture become much more clear. Then the data or some seed, as you will see here, or this is not really seed, but the let us just have it as the object. The object which we have in this image become much more clear. In brief, if I want to say about the image enhancement, I can call it its process of filtering the image. Really, what I have done on that image is that I put some filter to highlight the object more. And as you see, that gray color that we had in the original picture, it's something like the noise, which is removed, and contrast, which increase. Uh, and you see as the result, which the image quality is improved. Um, and the resulting image will be more suitable than the original image. As you will see, the result of this enhancement is much more better than the original image that we had. Okay, the next part can be the image restoration, which suppose you will see this photo, which is related to the moon, and the output which I show here. Let us see what is the definition for this block. We can call this is an area that also deals with improving the appearance of the image. However, unlike the enhancement, which is the subjective, image restoration is objective. Means that restoration technique tends to be based on some mathematical or probabilistic method of image degradation. Brief, we can call it this process will improve the appearance and reducing the blurring, etc. Some problem in that. and which some mathematical and probabilistic method which come to picture and help us as the tool to change the figure output or have the better figure output performance. That was the third box that we see. But um, what is the next part? Next part is color image processing, something like that, which we are going to see in the digital image processing. The shape that I show you in some referencing also it's showing like that. That is why I show you the figure like this. But the concept is same. Is that the title and concept are same? Just another representation of the uh, previous block. As I tell you, the next part is color image processing, which in that we are going to gaining its performance because of significant increase in the use of digital image over the suppose internet. This is may include the color modeling and processing in the digital image and etc. You will see one photo that I show here and some color processing which we have done on it, and as the output we shown here for you. Multi-resolution processing is the fifth box, which in that representing the image in the uh, various degree of resolution. How we will do that? We will use our some filter on a image, which in that the resolution of the figure become changed. Then as a result, we should expect that if we change the resolution, then the quality and appearance of the image should change. And you will see here that the quality and appearance also change. Wavelets and multi-resolution processing are foundation for representing the image in various degree of resolution and image subdivision successively into the smaller region for data comparison and for pyramidal representation. We will talk more for this image restoration later, and we have some chapter about all these key that I will show you here. The next part is morphological processing, which mainly some famous application we can call it in the fingerprint or palm recognition job. As you will see here, I have the fingerprint of one person, and then with the help of some work that we will say what is that work, we're going to have the better and much more clear and informative data from that. The morphological processing deals with the tools of extracting image components that are useful in the representing and description of the shape. It means that in that we are going to extracting the components of my image that are useful in representing and description of image. Little bit, if you see in the seventh box, we are going to give more meaning or some description or some elaboration regarding the figure that we have. Next part is segmentation. As you will see, these tools that I show here, we can have the segmentation. But let us see what is this segmentation. We call this as the procedure partition an image into its constituent parts or object. In general, autonomous segmentation is one of the most difficult tasks in DIP, and which RUG, the segmentation procedure, brings the process a long way toward the successful solution of imaging problems that requires objects to be identified individually. In brief, we can call this is the process of partitioning the image into the multiple segment. Mainly, we will divide or we will split our image into the different part. Currently, I don't want that you means that know all these subject, all these title. These are the keywords, and maybe we can say these are the chapters that we are going to review in our subject. But you should know what is the ended suppose for the segmentation. What is the aim for this segmentation? That is why we have this definition in today's lecture. Box number 9 is object recognition, which, or and other words, we can say something like classification. If you classify the image or can separate something from your image, you detect the object. In brief, we can call it this recognition is the process that assigns the label such as vehicle to an object based on its description. We can have the figure, and in that figure we can find that okay, vehicle is here, dog is here, cat is here, and so on. We can talk. Next box that we have, we can call it representation and description. In this part, almost always follows the output of segmentation stage, which usually this is the raw pixel data, and it can be consist consisting either the boundary of a region or all the points in the region itself. See this figure. I suppose have this shape. Then if I want to show the boundary or region that we have, first I convert it into the segmentation part. And then after that, the boundaries are become clear or highlighted from my image. Choosing the representation is only part of solution for transforming the raw data into the suitable form for subsequent computer processing, and description deals with extracting the attributes that result in some quantitative information of interest or are basic for differing one's class of object from another. In brief, we can say this stage it's involving the representing an image in various forms. One form is that boundary representation, which is focused on the external shape characteristics such as corners and inflection. Another form is regional representation, which is focused on internal properties such as texture and skeletal shapes and something like that. We will talk more regarding any of these parts later, okay? Just today is some description or something like introduction to each box we have. As you saw in my box, there was one box which we call it image compression. In image compression, we have some technique for reducing the storage which we are requiring to save an image or bandwidth or to transmit. One of the main problem that we had, and still we have, but it's become much more better, was the memory size that we need to store. Think for the digital cameras which we had 10 years back, and digital camera that we can say that that much use of digital cameras nowadays removed. Why it's removed and it's come to our mobile? Because they could work on this image compression. We're searching for the method to have the figure with as much as better quality, as much as informative, and as much as nice pictures, but with the less amount of the memory. You remember, as the computer person or computer science or computer engineering route, we always should take care of memory. Even if we work with the data, if we work with the image, and image are already is the data, then that is why we need some methods or some way to have the compression and compromise the output or image that we have. Particularly in the use of internet, this part is very important. Or when you want to transfer the image between, suppose, your mobile phone and your friend mobile phone, you will see that if the image size is big, then you have problem. Currently, even if we use the WeChat, you will see that you have the limitation to sending the image, 100 MB, something like that for the file, any file, okay? But if you can work on image compression or image, we can say that zipping the image like that, then you will see that you can send more number of image. This part involves the technique to reducing the size of image with a minimum deterioration in its quality. It means that we want to compress the image, but we don't want to corrupt the image. We don't want to make it gray or maybe change the quality of that. We want to have maximum data with the least amount of the size file size. Then this part we can call it something like WinZip, as I show here. That we are going to zip the image, and this is one of the key stage which we have in image processing part. There is some word that let me give more detail on this word, which we call it feature matching, which we can extract the same feature from different image. What I mean that um, these are something like seeing the one object or one event from different view. How it will help and what it can help us. It can help us, suppose, to know the dimension or know some specific specific data from an image from different angle or different view. One another word we call it recognition. It's the process to assigning the label to the object. Suppose here in this figure, we give the label to the trees. And if suppose I have this image and my aim is to counting the number of trees that we have in the image, simply we can find them, and also we can simply we can find and we can give the label to the image. Uh, One box we have as the box number 11, which we call it knowledge base. Knowledge base may be as simple as detailing region of image where information of interest is known to be located, thus limiting the search that has to be conducted in seeing that information. The knowledge base also uh, can be quite complex, such as an interrelated list of the major possible defects in the material inspection problem, or an image database containing the high resolution satellite image of a region in connection with the challenge detection application. This part, this knowledge base part, is more come to picture when you have some mission like inspection or audit or diagnostic part, suppose that MRI photo, if you remember, or some fault detection system which is going to have the elaboration of the image. This box will help us. As suppose you will see in this figure, we have some, I don't know which part of body is that, maybe it's lunge. And here they specify and finding some region in that, which if you will see this circle of the DIP as the processing job, you will see that they could specify some critical section in that, this red part and this um, yellow part or the blue part. These are the elaboration or knowledge that they could do. Okay, then in total, uh, if I want to tell you about whatever we talked today, we can say that in chapter 2, we of our book, we have image acquisition, then we have image filtering and enhancement. We have image restoration, we have color image, wavelet, compression, morphological process, segmentation, representation and description, object recognition, which all will go to give us the elaboration, or we are going to give us the information regarding the photo or the im- image that we have. Uh, if you see from chapter 2 to 9, the output of this process is generally our image. And if you will see from chapter 9 to 12 box, the output is generally our image attributes. This maybe some, not all, but some part from this chapter, we can say 8 to 12, we will have at least some preliminary work we will do, but not much more detail, maybe especially for the segmentation part and object recognition. Uh, if I want to give you more things in brief, I can say that for the image filtering, our result is suitable than the original. For image restoration, we can say that the work is improved the appearance. For segmentation, we are going to partition an image into the parts or object. For representation, we are going to represent the image for computer processing, and uh, it's finished like that. I bring this part from the reference because maybe the next lecture is much more bigger and we couldn't finish with this time with today. I think it's okay for today. Uh, let us have one key sentence, which and it's okay for today, I think.